Hello and welcome back to Apps for You. In this particular video, we are going to discuss a new problem from tree, and the problem is basically a zigzag traversal of a tree. So what does zigzag traversal actually mean? So we are provided with a tree. You can clearly see these are the nodes 797, 886 and 10 and 9, right? So this is the tree that is given to us, and we have to traverse it in zigzag fashion. So whenever we traverse the tree in zigzag fashion, we basically are asked to print in this order. Like 7 will be printed first, then when you move this side, so 7 and 9 will be printed. So please notice the direction. Then again 886 will be printed from left to right. Again you come here, 9 and 10 will be printed. But so please focus on the direction of the arrows, right? So basically first time 7 is getting printed, then reverse of 7 9, then again left to right 886, again from right to left. So left to right, right to left, left to right, right to left. This is the order, right? So this is basically called zigzag fashion, and hence we have to print the tree in the zigzag fashion. So you can see 7 is printed first, and then for the second level 7 and 9 is printed, third level 886 is printed, and finally in the last level 9 and 10 is printed. So how do we come up with this output, right? So we are going to get and develop this intuition that how are we actually going to solve this particular problem. So before that, let me write this tree and draw this tree. So first of all, let us draw the tree. So we have 7, right? And we also have 7 again here. We have 8. We have, sorry, this is 9, right? 9. This is again 8. This is 9. This is 8. Again we have 8 here also. We have 6 here, we have 10 here, and we also have something like 9 here, right? It's 9, okay. Anyway, so let us now try to solve this particular problem and develop an idea about how we are going to approach this problem. So we know that we have the address of this root node, right? So first of all, what we can see is the output that is getting printed is in this level. In this level the output is 7. From this level I am printing 7 and 9. From this level I am printing 883, and in this level I am printing 910. So you can see in this level things are getting reversed, in this level things are getting reversed, in this level also things are getting reversed. So it works like this, that the very first level I will be printing from left to right. So you can see left to right is getting printed. Again in the next level right to left is getting printed. Again left to right 883, 886, right? Sorry. So this is 886, not 883. And you can see that basically again in this level right to left is getting printed. So it is getting alternated, right? First time left to right, then right to left, left to right, right to left. So how can we achieve this alteration, right? That is, things are getting alternated, right, in alternate fashion. First level left to right, second level print right to left, again third level print left to right, again fourth level print right to left. So we are going to basically keep track of a variable flag which is initially 1, which indicates odd value. So whenever it is in an odd level, print left to right. In the next even level, print right to left. Again odd level, even level. Getting the point? What I'm trying to do? I am trying to say that level wise what I'm going to do is I'm going to increase the value of flag. So in the first level the flag will be equal to 1, which is odd. Next level flag will become 2. Third level flag will become 3. Fourth level flag will become 4. So this is the approach that I'm going to particularly follow, and it's quite simple to understand. So as I said, I'll be using a flag variable which will keep track of the level number. So whenever it is in an odd level, I'll print from left to right. You can see this is an odd level, so printing from left to right. Again this is an odd level, so printing from left to right. But if it is an even number level, then we are printing from right to left. Fine. So using the flag variable, we will be able to differentiate between left to right or right to left. So you will understand whether you have to traverse from left to right or right to left. Now the thing is, if I have to traverse from right to left, how will I ensure the input? How will I hold this input, right? How will I store this input? So I will be using a stack for that. Stack will be used for that. So what I'm going to do is, I'm going to do the algorithm will be something like this. The algorithm says that perform level order traversal. So I'm going to perform a level order traversal. Second, so After performing a level order traversal, what I'm going to do is I'm going to basically, after all the nodes of a specific level is stored in the queue, I'm going to traverse the queue, okay, and accordingly store the elements. So I'll show you. This will become clear with the help of example. Let us just write the code. So as I said, first of all, I'm going to write a code for level order traversal. So I'll be very quick because we have discussed many times the level order traversal. So you can again see this is returning a vector of integers. So again, as usual, vector int output is required. Similarly, come inside when the function Zig Zag traversal will be called, output.clear. Call the function solve, which will actually perform the operations. Root will be passed, and finally when the solve function will be executed, output vector will be updated. So we basically, after returning, have to update a return output vector. So return output. That's it from this side. Now basically you have to write the function for solve. Now solve function will be a void type function. What it is receiving is a root node, and we are going to perform level order traversal here. So for that, we know the very first thing that we do is basically check if root is not empty. So if root equal to null, we know what happens. If root is equal to null, we basically return, right? This is for sure, right? This is the one of the fundamental basic condition for level order traversal, that whenever root is equal to null, just return. Otherwise what we do, we are going to push the root node into the queue. So for that we must first of all declare a queue. So I'll be declaring a queue as queue of pointers. This is what we do, name it queue. Fine. So queue dot push, what are we going to push? The value of the root node, right? So the root node is going to be pushed into the queue. So I hope you have understood these things. So let me just erase this thing. So if you have understood this, let me just erase this. So if I just erase this and this also, fine. Now let us understand how we are going to work. So I have just declared a queue, and since I have declared a queue, let me write a queue here. So I have a queue, and this is my queue. Great. What next? What is the first element you pushed here? I just pushed the first element, that is 7. The address of 7 actually has been pushed here. Done. What next? Now you are going to basically traverse. So one more thing, I need to declare a variable. Okay, so I'll be declaring a variable integer flag is equal to 1 initially, because it is pointing to the first level. Okay, now what will I do? Now while you just say that while not queue.empty, while my queue is not empty, I'll just get in because I have already pushed one of the element. I will first of all find the number of elements in that specific level, that is basically put into the queue. N is equal to queue.size. Done. After you do this, I will check what is the level number. So if flag modulus 2 is equal to 0, right? So I'll basically check the level number. So if flag modulus 2 is equal to 0, what does it indicate? It indicates that it is an even level. Otherwise it indicates that it is an odd level, right? So as I said, initially my level is what? Odd, right? Flag equal to 1, so odd level, because this is the odd level, level 1, right? So whenever we are in odd level, what do? We push the elements from left to right into the output vector, right? I will be having an output vector also, so let me dot the output vector also. Fine. So right now my queue has element 7. So first of all, I will decide whether my level is even or odd. So since my level is odd, what I'm going to do? I'm going to do the else part, because my flag is equal to 1. Now in the else part, I'm going to declare a pointer struct node star current, and it will basically point to the front node of the queue, right? Queue dot front. So basically pointing to node 7, this node. Done. What next? Now it's pointing to node 7. So basically in the else part, you should first of all traverse from I equal to 1, I less than equal to n I plus plus. What is n? N is the size of the queue, remember? Let me just make it clear. Sorry. Yeah. So if you remember, here we have declared the value of n in line 130. What does it indicate? It indicates what is the size of the current level, means how many elements from the current level have been pushed into the queue or are actually present in the queue. So right now, how many elements are present in the queue? Obviously only one element, right? So right now, obviously only one element is present in the queue. So let me just, where it is, okay. So 1 to n, because you see I have just pushed one element into the queue here, root node, and then what did I do? While queue is non-empty, I'm just finding the size of the queue. Right now my size is 1. So if flag modulus 2 equal to 0, is the level even or odd? So right now my flag is equal to 1, so odd level. Fine, so don't do anything here, just come to the else part. In the else part, I will traverse all the element in the queue in that level. So right now I have only one element in the queue, so I will make my pointer point to that particular node. Done. What you will do now is basically you will say q dot pop, sorry, in small letter, q dot pop. Done. And you will just push into the output dot push back into the output vector the element current data, right? This is what you have to push, because you can basically normally push it, because the level order traversal, what we are doing right now is level order traversal, and we know that level order traversal is operated from top to bottom and left to right. So basically whenever I am in an odd number, whenever my flag is odd, that means whenever I am in an odd level, I can simply push the elements, because it is automatically going to be pushed in left to right fashion, right? So odd level, definitely I have to follow left to right fashion, right? So because you can see this has to be performed left to right. Now second level will be right to left, third level again left to right, fourth level again right to left. Done. So anyway, so whenever I am in an odd number level, what I have to left to right fashion. So left to right fashion, directly you can just say output dot push back current data. Whatever element is there, just push into this. So basically this has been popped by this line. Next line I'll push 7 into the output vector. Done. What next? You have to basically push the children of this particular node into the queue. So basically I'll be checking if current left is not equal to null. What should you do? You should push its element. So current, basically you say q dot push current left. Got the point? Otherwise, if current right is not equal to null, what do we push is basically q dot push current right. That's it. So I hope you are getting the point that basically if my left element, if my left child is not null, then I'll be just pushing it into the queue. If my right child is not null, I'll be pushing it into the queue. That is what I'm basically doing here. What next is basically, this was all about the odd level. Okay, odd level. Whenever I'm in the odd level, you just have to perform these steps. As you can see, just point to the front element of the queue, pop it, push it that normally into the output vector. Okay, so my output vector right now consists of 7, and then just push its child into the queue. So what is the child of 7 is 9 and 7. So 9 and 7 are again pushed into the queue as normal. Okay, so fine. So next time I will basically, what will I do is basically I'll do flag plus plus, because you have to increment the flag now. Okay, after you have done all these things, just say flag plus plus. Okay, don't do flag plus plus inside the for loop. Once you have completed the traversal of all the elements in this loop, then you say flag plus plus. Fine. It indicates that now you are into the next level. So next time my again queue will be non-empty. Next time my queue will be non-empty, and this time my flag value is what? 2. Okay, now my flag value is how much? 2. So you just come inside n equal to q dot size. What is the size of the queue right now? Right now my queue size is 2. So queue size is basically 2, and your flag modulus 2 equal to 0 is again true. Why? Because your flag is now 2, which indicates you are in an even level. Even level, right? Because I am now, this level is complete, I am in this level which is actually even. So if you are now in an even level, what you have to perform? So whenever we are in an even level, whenever my size is 2 and flag is true, whenever I am in an even level, what will I do is basically, you see, same thing. So I'll just copy this, make a pointer, point it to q dot front, pop that element. So pop that element. So basically what happens, q dot front right now is 9. So your current pointer will point to this node, 9th node, and pop it from the queue. And now since it is an even level, so what will you do is you will basically traverse all the element of this. So see, you will not push anything right now. Okay, you will not push anything right now. So it should be actually like this for I equal to 1, I less than equal to n, because I'm traversing all the element, right? And inside this I'm performing these operations. Now point to be noted, a very interesting thing. So since it is an even numbered level, I know that in the even numbered level all the elements should be pushed from right to left. You can see right to left, it is clearly written in flag 2 and flag 4, because they are even level. You have to perform right to left numbers, you have to pick the numbers from right to left. How can we do so? So basically you can see your numbers that are pushed into the queue are 9 and 7 in the left to right fashion, and I am just accessing those elements. Right now my I value is how much? 1. I equal to 1, I less than equal to n, which is 2. 2 times this loop will be iterated. Now what you do is basically while iterating you just push the elements, that is stack dot push current data, push those element into a stack. And so I am using a stack, so basically let me declare a stack above. So I will say stack of integer stack. So what did I do? You are now right now traversing the second level, so element 9 you are pointing to, so you have a stack, you push 9 there, done. Stack dot push current data, and then if it has got any children, push their children into the stack. So that is why I am just copying these lines, same thing, nothing else, done. So this their children will also be now just pushed into the queue. So you are just pushing 9 into the stack. 9 has any children, so 8 double 8, so basically double 8 are going to be pushed here, right? And 9 I have pushed into the stack. Next time your I will be 2, because I have to traverse from 1 to 2. I will be equal to 2. So you have already popped 9, so now your front is 7, so your now current is pointing to this node 7. So again what you have to do, you have to push it into the stack. So I am basically pushing into the stack, done. This step is done. 7 has got any children? Yes, 6 is the children, so basically push 6 here, 6 is the child, done. 7 is popped from the queue. Now you see this 7 and 9 I have pushed into the stack. Why did I push into the stack? Because I know that I have to pick this element from right to left order, but they are present left to right order in the queue. So for reversing their order I am just using a stack. Now my stack consists of all the elements of this level, right? All the elements of this level, but in the reverse order. Now what will I do? After this for loop is successfully executed, just come out and say while not stack dot empty. Until your stack is not empty, what you are going to do? You are going to push back into which output vector. So you are going to say output dot push back. Output dot push back which element? So basically the top element of the stack. So stack dot top. Fine. And you're just going to say stack dot pop in the next step. Done. And as always you are going to say flag plus plus, because I am going to the next level. So what happens? You can see this element will be popped and put into this output vector. Again this element will be popped and put into the output vector 9. Fine. So next time your for loop will not be executed, because it will be executed only 2 times. So next time your flag becomes how much? 3. Now you are going to the while loop again. While queue non-empty, definitely non-empty, because I am now with the third level elements, this level element. So what will happen? N will be equal to how much? The size of the queue is nothing but 3 right now. So n is equal to how much? What it is? Yeah, n equal to 3, because you have 3 elements in the queue right now. Is it even or odd? So basically flag is even or odd. So flag is basically 3, it indicates I am in the third level, so odd numbered level. So I will not execute this thing right now. Where will you go? You will basically go to the else part. Now since you are going to the else part, what we are going to do in the else part? For I equal to 1, I less than equal to n is 3. So 3 times you will be iterating this loop. Every time you are going to pick up an element and push it into the output vector. So which element? 8 will be pushed into the output vector, this, and it will be popped. Its children, if any, will be pushed into the queue. So 10 and 9 are pushed into the queue. Similarly go for 8, pick this element, okay, push it into the output vector, pop it from here. If any child, then push them. So no child, no problem. 6 will be picked up, popped, pushed here. Any child, then push into the queue. No child, so let it be. So you see this for loop has been completely executed, and we have the output vector right now as this. Fine. Now next time your again queue is not empty, because you have the element of the last level. What is the flag value now? Flag value will be equal to 4, because we have performed flag plus plus here. Now when your flag value will be equal to 4, what happens is basically only your if part will be executed, because you are now in an even numbered level. Whenever I am in an even numbered level, I will be basically trying to reverse that element using stack. So what happens, your stack, this stack is right now empty. So you will traverse from 1 to 2 because right now you have 2 elements in the stack. Initially pointing to node 10, pop it, stack.push current data, so push 10 into this. If 10 has got any children, push them, otherwise continue. No children, go back. Next time your I will point to this 9, so stack.push 9, done. This is popped from here, and if it has got any children, push them into the queue, but no children, no problem. No, for loop will not be executed, come outside. While stack is not becoming empty, you just try to pop an element from the stack and push it to the output vector. So pop 9, push in the output vector. Pop 10, push in the output vector. Done. This job is also done. What is the flag value? Flag value is now 5. Come outside. While queue non-empty, but your queue is now empty, nothing to do. That's it. Right now, what is the status of your output vector? You can see your output is 779886. 779886, 7798, this is 8, okay, sorry, 886, and then you can see 910. So basically you are traversing it in this fashion. What the point? You can see this is what we require, right? So after the successful completion of this function solve, the output vector is already updated, and when we return it, we will get our desired answer. So let us see how it works. So we will just now compile the code. Expecting no error. Maybe I have not declared variable I. Yes, this is what I was doubting. So let me just declare the variable I outside, comma integer I, done. So right now if you see, what happens is basically, if I compile the code, so I was not declaring the scope. Okay, let us declare the variable I properly. Let me clear the screen. So where is it? Okay, sorry, this should be just integer I. Yeah, that's fine now. So compile it. So I hope you have understood the working, how the things are actually working. We have just implemented a trick that keep track of the level number using flag. Odd numbered levels we will perform normally. Even numbered levels we are just trying to use a stack to reverse the elements. So if you look at this example, the tree is like 3 2 1, and the output will be basically what, 3 1 2, because you are traversing like this, right, zigzag, and this is the what output you have received. So yes, that's all from this particular video. I hope this video was helpful. Let us see if this particular problem successfully passes for all test cases. Yes, exactly. So we have successfully executed the code. Now in case of any doubt, feel free to put it out in the comment section. Just like, share and subscribe. Considering the time complexity of this code, obviously we are performing level order traversal, visiting each node exactly once. Time complexity order of n, space complexity also order of n, right? So yeah, that's it from my side. I hope it was helpful. Please like, share and subscribe. Thank you.